At the edge of the Gobi Desert, where the ground hasn't moved in 80 million years, a geologist knelt down and placed their hand on stone. The rock was cold, not cool. Cold in the way that means deep time. The kind of cold that comes from being buried and exposed and compressed by the weight of epochs. Under that bare palm was a moment frozen in time. The moment the world ended, then began again. We talk about deep time in abstractions. Millions of years. Geological epochs. Names like Cretaceous and Paleogene that slide off the tongue without friction. But when you stand in the Gobi Desert and you touch the actual rock face where those epochs meet, where the rocks literally change color, literally transform from one age to the next, the abstraction becomes weight. 80 million years. That's not 80 dates. That's 80 million sunrises, 80 million rainstorms, 80 million creatures being born and dying. All of it pressed into the thickness of your hand. To put that in perspective, modern humans have existed for roughly 300,000 years. Everything you know about civilization, writing, cities, art, science, happened in the last 5,000. All of recorded human history, every empire that rose and fell, every war and peace and invention and discovery, is a rounding error in the time this rock spent underground. The Gobi Desert holds something most deserts don't. Evidence. Evidence of when the world was radically different. Geological formations stretch across hundreds of miles, layer upon layer, each one a chapter in Earth's story that most people will never read. The dream was reading one story written in stone. The story of the Cretaceous-Paleogene Boundary. The moment 66 to 80 million years ago when something catastrophic happened to our planet. Dinosaurs had ruled for 165 million years. Then, in what felt like an instant in geological terms, most of them were gone. But the boundary isn't invisible. It's a physical line in the earth. In some places it's marked by a thin band of iridium, an element rare on Earth but common in meteorites. Evidence of impact. In other places, volcanic ash, shock quartz, tiny glass spheres formed when rock melted from impact heat. Each marker a whisper from a world that ended. The Gobi holds its own version of this story. And when you find it, when you're alone in the desert, and you trace your finger along the rock face and you feel the exact moment of transition from one world to another, something shifts in how you understand time itself. This isn't abstract anymore. You're not reading about it. You're touching the grave of an entire age. Your hand is spanning millions of years. But here's what makes this discovery extraordinary. Most boundary layers are disrupted. Time isn't clean. Earthquakes, weathering, water flow, they all scramble the signal. You find the evidence, but it's mixed up, partial, ambiguous. In this section of the Gobi, the layers are undisturbed, pristine. A perfect chronological record of that catastrophic moment written in stone so clear that every layer tells a different part of the story. Volcanic ash from the impact, then a pause, then the recovery begins. You can read the planet's response to the cataclysm in the sequence of rocks, which means you can understand not just that something catastrophic happened, but how life recovered, how the planet healed, how a world ruled by dinosaurs became a world that would eventually give rise to mammals, then us. You might ask, why does any of this matter? Dinosaurs are extinct. The Cretaceous is ancient history. We don't live in that world anymore, but we do live in the shadow of it. The mammals that survived that extinction event were small, adaptable, resilient. They survived because they could live in a world that was broken and rebuilding. Somewhere in those 80 million years, their descendants became us. And more immediately, we live on a planet that we've learned is not stable. It's not patient. It responds to shocks, whether from asteroids or volcanic eruptions or, now, from us. Understanding how the planet recovered before gives us a map for understanding how it might respond to the shocks we're creating now. When that geologist knelt in the Gobi and pressed their hand against the cold stone, they weren't just reading the past. They were asking a question about the future. How resilient is this system? How long does recovery take? What does the pathway from catastrophe to equilibrium look like? And the desert, in its indifference, gave an answer. Slow, difficult, but possible. The hand on the cold stone. That's where the real science happens. Not in the naming, but in the touch. Not in the knowing, but in the standing still before what you know and letting it be larger than you.